an hourglass depends on the bulb size, the neck size. This is the neck.
Hello students.
Okay, that is the neck.
Welcome back to
Everything else is the bulb. These two are the bulb.
And today we're going
And
to
the material, that is also the sand
integers.
used. How soft the sand is.
Number 2.
Ultimately, what is the thing? An hourglass or a sand smartwatches are used.
So 41 is
Okay.
equal to 41.
Understood?
What I can say?
So that's good, everyone. So we have learned about time.
Numbers. Yes.
We learned about different units of time. We learned about different measurements of time and how ancient people also used to measure.
From this I can say that yes.
Okay. Okay, that's good. So thank you everyone. Thanks a lot.
Right. They have associative property relation under addition. Let's not fix it for now. Let us take one more question about that. So what is the next question? Minus 9 plus 11 plus minus 4 and minus 9 plus 11 plus minus 4. So the thing is, first we'll try to have brackets. Okay, whenever you have bracket, be calculated first. That's a group out. Okay, so minus 11 minus 2 is 11 minus 9 is 2 minus 4. Okay, 2 plus minus 4 is nothing but 2 plus into minus, positive into negative will give 2 minus 4 is 2 minus 4 is minus. What about this one? 11 minus 5, discuss about 11 minus 7 minus 4, 9. Sorry, 7 minus 4 is 7. So minus 9 plus minus 9 plus 7. Yes, these two are equal. Numbers may be positive, the integers it can be. So for all these, this property is valid. A plus and A plus B plus 2 and then add the last 2 and then you add. Integer is not important. Whole numbers, integers, later we'll discuss about that. In addition, no add in any way the last. Right? That integers are under addition. So it means that relation is B plus C, B plus C. Okay. The same property with minus subtraction, if that is valid or not. The first one we're having here is B minus C and A minus B minus C. What are we going to do here? We have three numbers A, B, C. We are trying to find the difference of one another. So first we'll try to find A minus B and then we'll try to find the difference with C, or find B minus C and find the difference with A. So the point is whether these two will be equal or not, that we need to verify. So what is that we can say? Let me try to take the same example with all the negatives. Okay. So minus 9 minus 11 will give you minus 20. Minus 9 minus 11 will give you minus 20, and this minus 2. Minus 20 minus 2 will give you minus 22. Minus 20 minus 2 will give you minus 22. What about this one? 11 minus 2. 11 minus 2 is 9. Okay. Minus 9 minus 11 minus 2 is 9. So minus 9 minus 9 becomes minus 18. So now tell me, are these two equal? Are these two equal? No. Why are we getting this difference? Why are these two numbers not the same? Because we have a property negative into negative is a positive. Negative into negative is positive. So here you can see all these are negatives. That's okay. Minus 9, minus 11, minus 2, we got minus 22. But here minus 9 is correct, minus 11 is correct, but minus of minus 2 will give you plus 2. Minus of minus 2 will give you plus 2, and that is the difference. That is the value. That is the way we are getting minus 22 here and minus 18 here. So we can say that these two are not the same. These two are not the same. A minus B minus C and A minus B minus C. These two are not the same, right? So we can say that integers are not associated under subtraction. Integers are not associated under subtraction. Okay. So you should be very careful. These are not. Okay. So I can say that these two are not equal. A minus B minus C and A minus B minus C. These two are not the same. Okay. So it is confirmed. For subtraction it is not valid. Let us try to see for multiplication and then for division. So the same multiplication also, A into B into C and A into B into C. Let us try to apply that. Okay. So for multiplication, let us try to find the product of A and B and then with C, or product of B and C and then with A. Right? So let me take small question. Okay. So minus 9 into 11. 11 nines are 99. We have a negative. So minus 99 into minus 2. minus 99 into minus 2 is equal to, okay, minus 9 into 11 into minus 2. The first one is 11 into minus 2. 11 2 is 22 with negative. Minus 22. Now, 99 into 2. What is 99 into 2? 99, 9 2s are 18, 9 2s are 18, 119. Okay, so 198, correct? 99 into 2 is 198. So negative into negative is again positive. Negative into negative is positive. So it becomes a plus 198. Plus 198. And this one, 22 into 9. 22 into 9. 9 2s are 18. 9 2s are 18 and 19. Yes. So this is also equal to 198. With negative into negative is again positive. So these two are equal. Not only this one, you can take any numbers, positive, negative, zeros, every number, every integer. So in associative property, multiplication is valid. That means that relation is correct. It is true. We can multiply in any order. Not only in integers, say when you take natural numbers, when you take whole numbers, when you take zero as well, when you take positive, negative, whatever the numbers, multiplication, you can multiply in any order, you'll get the same answer at the end. You can multiply in any order, just like the addition. You can add in any order, right? But not subtraction. So what I can conclude here, integers are associative under multiplication, okay? So that means associative properties are valid for integers. Integers are obeying the property of associative, right? So addition, yes. Subtraction, no. Multiplication, yes. Now let us discuss about division. Same way like this, A divided by B divided by C and A divided by B divided by C, right? So let us try to look into that. So A divided by B, first we need to find the quotient of this one, and with that you need to divide with C. First find B divided by C with that value, A divided by that value, and we need to find whether these two are equal or not. So let me take small question. Minus 12 divided by 3. 12 by 3 is 4, correct? 12 by 3 is 4. So 4 and we have a negative minus 4 divided by 2. Minus 4 divided by 2 will give you minus 2 as the answer. Let us check